Well, some of you might be thinking that that was rather complicated.
I agree.
And I can understand that. But I'm going to try my best to review it and maybe explain it in another way.
I can't wait.
Well, good. That's great. So, here's it is from a computational viewpoint. We start with our linear first-order differential equation. We make the coefficient of dy dx equal to 1.
Make it so, number one.
So we'll make that so just by dividing by a1x all three of these terms, and then so we do have that as a 1, and that'll be some function p of x times y, and that'll be some other function f of x. So we got it in the right form. Then we will find what's called the integrating factor, e to the integral p of x dx. That is the integrating factor. And then what we do is multiply both sides of this equation by the integrating factor. See, e to the integral p of x dx times dy dx plus p of x times y times e to the integral p of x dx equals e to the integral p of x dx times f of x.
Are you trying to give me the double talk?
Well, perhaps, but not intentionally. So, here's what happens. The left-hand side, and this is very tricky to see, but I want you to look at the left-hand side really carefully. That's all this. And notice that this is the product rule applied to e to the integral p of x dx times y. Now, I'll show it to you. It's first d second. Sorry, here's the d second. I'm trying to highlight just this there. First d second plus second, which is y, d first. Well, how do you find the derivative of e to the integral p of x dx? You would just say, well, it's e to the integral p of x dx times the derivative of whatever this function here is, and the derivative of an integral is the function itself. So indeed, the left-hand side, look at it again, you'll see it, is the derivative of e to the integral p of x dx times y. Of course, the right-hand side, we already multiplied that out, and we have this. Now, are you starting to see how this goes?
I don't understand.
Well, you might not get it yet, but we're getting kind of close to a solution.
I know.
All right, well, here we go. Now, since the derivative, on the left side we have the derivative of an expression, on the right side we have some other expression, would you agree that all we really have to do to get out of that is to integrate both sides?
I think that this is your way of telling me something.
Yes, it is. And if we integrate a derivative, we wind up with just what we had here in the parentheses. Integrating that will give us this. Of course, there's a constant of integration involved. And then we will integrate the right-hand side. Well, we don't know what it is. It's integrating e to the integral p of x dx times f of x, whatever that is, but we would have to multiply that out to c. Then we multiply that out, and this is, since we're integrating both sides, this is the constant of integration c, which will be for both sides.
I know.
Okay, good. Now, remember, we're ultimately trying to find y. So in order to find y, all we'd have to do is divide both sides by the part that I have highlighted here.
I can't wait.
So here we are. Well, I didn't say to divide by that, but really I'm multiplying both sides by e to the negative that, and you understand that that's the same as dividing. So we wind up with y equals e to the negative integral p of x dx times the integral of e to the integral px dx times f of x dx plus c. So this can be written, here's the c times this part in the front, and by the way, you might recognize that that is our yc from the previous video, and this is e to the negative p of x dx. This part is here. So you might even see it written like this instead of this e to the negative integral of p of x dx 1 over e to the integral of p of x dx. Sometimes you'll see it written like that. Now, I apologize for my software writing things even that are exponents of the same size. as the things that are on the main line, but it's the way the software is, so that's the only thing I can do with that.
I can't take this!
Well, sorry, but I hope it's better than my handwriting. So let's go ahead and solve one in the next video.